Thank you, Avit and MX Business Media for organizing this event and making this possible. Thank you also to our sponsors, BIMSTAR and Steel Structures and Metal Buildings Magazine. But mostly thank you for being here, those of you in the audience that are attending here. It's an honor to have the opportunity to talk about information modeling in India, because India is one of the places where massive investments in infrastructure is underway. And there's an opportunity here to do it right the first time. Right? So when a lot of in the developed world where infrastructure has been in place for a long, long time, these tools didn't exist. And so now we're having to rebuild the stuff that we should have built right the first time. You have an opportunity to do that now, and it makes it particularly exciting. So I'm delighted to be here. So I'm going to talk a little bit about Bentley here at the beginning. So starting with our mission statement. And our mission statement is to provide software and solutions to the enterprise and professionals who design, build, and operate the world's infrastructure. So a couple of key points there. The first is that we focus exclusively on infrastructure, and I'll describe what we mean by that. And then secondly is that it is the entire life cycle. So it is design, it is construction, and it is operations. It's also well understood that the quality of life for our citizens is directly proportional to the quality of our infrastructures. So it's thrilling for me to come back to Mumbai. I didn't get here last year, but I was here the year before. And since then, new international airport. You just opened up the Mumbai Metro. And those are big infrastructure projects that will immediately have value to the citizens in and around Mumbai and in fact, all of India. So great to see that kind of thing going on. So we issue an annual report. Even though we're a private company, we view our users around the world as our shareholders, if you will, and we feel an obligation to tell you how we're doing every year. So a few things out of the annual report. This is our centerfold. This is everything that we consider to be infrastructure, and it really is the entire built environment. So it's anything under the ground, on the ground, over the ground. So it's rail networks, it's road networks, it's bridges, it's building, it's power plants, water and wastewater treatment facilities, and so forth. It truly encompasses the entire built environment. ARC Advisory Group published a research report last year looking at our industry. Their focus was engineering design tools for plants and infrastructure. And we're happy to see that we showed up as number one in a variety of important categories. And then in Forbes magazine, the PwC Global 100 Software Leaders was published. We showed up on that list as number 70. And if you looked at only those software companies that get 50% or more of their revenues from software, we end up as number 43. And it's nice to be on a list that includes, companies like Google and Microsoft. So back to our looking at our revenues over the last 5 years, you can see that we are a steady grower, but we're not an outstanding grower, right? It's relatively modest, upper single-digit kind of growth. Part of the reason for that, or a major reason for that, is that 70% of our revenues comes from subscriptions. We think that's a better model in terms of how we work with our users, and as a result of that, we don't have high fluctuations in our revenues, but also our revenues are a lot more predictable. We have a commitment to continue reinvesting 20% of our revenues back into R&D at a minimum, and you can see that over the last several years we've exceeded that, almost 25% in 2013. And in terms of where our revenues come from, 45% in Americas, another 36% in Europe, Middle East, Africa, and the remaining 19% in Asia. Then in terms of our colleagues, and we're roughly 3,000 colleagues around the world, I like to say we live where our users live. We have a slight overweighting in Asia. That's two reasons. Number one is we're investing ahead of the growth that Asia represents. But number two is that we have, in each of China and India, we have development centers here. In fact, outside of the U.S., the number one country for us in terms of number of colleagues is India, and we're very proud of that. So every year we ask our users to self-nominate projects for consideration to win one of 25 different awards given in various categories of infrastructure or technology. We typically get about 300 nominations, and we publish those in a book. Each of those nominations is reviewed by an independent jury, and 3 finalists are selected in each category. We then bring those finalists to a single location. In the last 2 years, it's been London. They present their projects in front of the jury and in front of their peers. A winner is selected. We have a banquet that night. I refer to it as the Academy Awards of Infrastructure. It's a lot of fun. India's been a tremendous participant in this, and I'm really, really happy to report that in our 2013 Be Inspired Awards, we had 2 winners from India. So the first is Paul India and their jet pulse blowback filtration system, and they won in the category of innovation in process manufacturing. And then the second was Shibani and Kamal Architects on the Bao Institute of Innovation, Entrepreneurship, and Leadership, beautiful building, and that was innovation in structural engineering. So congratulations to those 2 firms, and really congratulations to India for your participation and your competing at this global stage very effectively. All right, and so to our topic of information mobility, and the goal here is to give something of a global perspective of what's going on in BIM, and Avita set this up very nicely, and I'll try not to repeat too much of what he said. If it's done right, the idea of information modeling is that it flows through the life cycle of an asset. Right, so it begins in design, it then moves into simulation and fabrication and so forth, all the way through to operations. And the idea is that this lovely digital data is, in fact, a process and a life cycle. Right? And it actually comes back and feeds back into yet the next projects as we renovate the assets that we previously built. So that's what it's supposed to look like. But the reality is that we have information mortality. That rich digital data never escapes design, and whatever we produce in construction never makes it to operations, right? So we have this mortality that goes on, and so this rich information isn't useful and doesn't really helpfully inform the next life cycle. So one way of picturing this, or why is this happening, is if we're looking here at the various cycles of a life cycle. So we create this information, we print, we lose data, we print, we create some more, and then we print. And each step along the way, we are losing massive amounts of data. And we could imagine, and the reason for that is that these are in fact silos. It's not a continuous process, right? We could imagine that instead of being silos, we in fact have a process and we don't lose any data along the way, and nor do we have to collect or recollect so much data. So it's a lot more efficient, and we end up with a whole lot more data, and we got a huge benefit as a result of using information modeling. So that's sort of the picture that where we want to get to. So the thing we need to do is stop printing. Because printing is where we kill the digital. It's the enemy of digital. As soon as we print, we're in trouble. Because as soon as you lose 5%, 10% of your data, you might as well have lost it all, because you don't know which 5 or 10% you lost. So it's all garbage. The truth is. So we got to find a way to stop printing. Good news here is the world has moved on in terms of technology, not driven by our industry, but certainly driven by consumerization, to allow this to happen pretty efficiently. So for one thing, the internet, which has been around now for a couple decades, is pretty much everywhere. We all have access to that. Wireless now we can have right down to our job sites, right? So that's pretty much everywhere in the world. mobile devices, each of you at least has one on you, and most of you probably have three. Right? So we can have information, real-time information, right now, right here, and that didn't exist before. Right? No need to be carrying paper. Scanners. They've gotten a lot less expensive. Your iPhone will soon be a very effective scanner of capturing as-is information and incorporating that into our infrastructure workflows. And then the idea of sensors. Now, sensors can be wonderful in a couple of categories. In the construction area, being able to tag everything on a site so that we actually know where it is going to be tremendously useful to us. In terms of this waste that Avit talked about, this will be one of the things that helps us dramatically. But in addition, we can put sensors on existing infrastructure projects to be able to record real-time performance. So you can imagine having a sensor on a bridge telling us how the vibration of a bridge is going on. And if we have that sensor, we can then be reading those in real time and fixing the bridge when it needs to be fixed. Because fixing a bridge after it breaks is real expensive. So the point is that we have ubiquitous computing. All right? So that's the world we now live in. And because we have this, maintaining our workflows in the digital realm is possible. We just have to change the way we do business. We have to break down those walls between design, construction, and operations, and we have to change our mindset and our processes. So we see this as being done, information modeling, through an integrated project for the benefit of intelligent infrastructure. And I'm going to talk through each one of these. So beginning with information modeling. So this idea of a global BIM perspective and what's going on, and Avit did a nice job of showing you the country, sort of where things are happening. McGraw-Hill published a report in 2012. It was the business value of BIM for infrastructure. They asked a series of questions and collated all the information and then reported that in their report. So here's one of they asked people, where are you in terms of your BIM adoption? And the good news is that the majority of people say, we're just scratching the surface. So does that describe anybody in the room? We're just scratching the surface? How many of you are advanced, already there doing BIM? All right, a few. How many are you doing nothing? Not even scratching the surface, haven't found the surface? Okay, a few. I suspect most of you are in that just scratching the surface or just don't want to say so. All right, but that's the good news is, hey, we're all one big happy family. We're learning this together. So it's not like you're hopelessly behind. You're just like everybody else. So it's an opportunity to seize the day. One of the other questions they asked is, in terms of your BIM implementations, when do you think over half of your projects will be using BIM? And this was across a variety of infrastructure types, basically everything we build, right? So this was done in 2011. So the 2009 results are theoretically actual results. And at that point, roughly 20% of the firms said half of our assets we design using BIM. And by 2011, they're saying now that's up to roughly 40%. And they're projecting that by 2013, we're going to be at about 60%. Now, what we don't know is what do people mean when they say BIM? That's kind of why we're here today. What the heck does BIM mean? So I would suspect that most of these people really think BIM means 3D. It doesn't. But the obvious thing we can take from this is we're moving this direction as an industry. Right? This is happening. We can't ignore it. Right? In fact, we have to embrace it. So this global perspective, starting in Singapore. So the Building Construction Authority of Singapore defined a program to incentivize early BIM adopters, and it introduced a 6 million Singapore dollar fund in June of 2010 to cover costs on training, consultancy, software, and hardware. And the BIM fund aims to help firms adopt BIM technology into their work processes and improve their productivity. And as Avit said, Singapore now mandates the use of BIM on capital projects for the government. As we then move to the UK, the United Kingdom government BIM task group, working with industry, piloted the use of BIM over a 4-year period, supporting that BIM could reduce costs by 20%. They concluded that information-rich BIM technologies, process, and collaborative behaviors could unlock new, more efficient ways of working at all the stages of the project lifecycle. Published by the Cabinet in May 2011, the government announced its intention to require collaborative 3D BIM on its projects by 2016. So if you want to work for the UK government, and they represent 40% of the capital spend in the UK, you're going to use BIM by 2016. So you can imagine that all of the infrastructure professionals in the UK are rushing towards BIM. So moving now to Norway, Statsbygg is the Norwegian government's key advisor in construction and property affairs, building commissioner, property manager, and property developer. Statsbygg manages approximately 2.7 million square meters of floor space in Norway and abroad. And Statsbygg has laid the foundation for better and more efficient building processes and the management of buildings by using and making BIM technology suitable for the building industry. Statsbygg uses BIM for all of its new building projects. Moving to its neighbor, Finland, the Senate Properties is a government-owned enterprise under the aegis of the Finnish Ministry of Finance and acts as the government's expert on the working environment and working premises. Based on the BIM requirements published by Senate Properties, in 2012, Building Smart Finland assisted with developing CoBIM, the Common BIM Requirement. This document provides guidance from modeling requirements to quality assurance, energy analysis, through the use of models in facility management. We head now to the U.S. Beginning in 2007, the U.S. General Services Administration, or GSA, adopted the use of 3D, 4D BIM programs for all capital projects. As the country's largest procurer of construction, the GSA believes that these data-rich, interactive data models will benefit the industry in the long run by improving decision-making processes. Moreover, the GSA hopes to improve interoperability and efficiency by creating an industry-neutral standard for construction projects. To date, the GSA has published 5 BIM guides spanning from spatial program validation, 3D laser scanning, 4D phasing, and energy performance. COBE, the Construction Operations Information Exchange, is defined in the U.S. National Building Information Modeling Standard. It has received global attention as the leading definition for the transfer of design and construction data for operations. So one of the big questions is, how detailed should the graphical representations be, and what data should we collect? The U.S. BIM Forum has defined the level of development, or LOD, specification. Its primary objectives are, 1, to help teams, including owners, to specify BIM deliverables and to get a clear picture of what will be included in a BIM deliverable. 2, to help design managers explain to their teams the information and detail that needs to be provided at various points in the design process. And 3, to provide a standard that can be referenced by contracts and BIM execution plans. So we then head to Australia. The National Building Information Modeling Institute, or NBI report, was authored by Building Smart Australia in 2012. The National BIM Initiative report comprises 2 volumes. Volume 1 strategy, what needs to be done. Volume 2, implementation plan, how it should be done, and detailed costings and time frame schedules. The report states the Australian economy could be better off by as much as $7.6 billion over the next decade by adopting the NBI recommendations. Can we afford not to take action? And I really think that that is the key point. Can we afford not to take action? And that means you in this room. That means all of us in the infrastructure field. That means also the governments of the world, and you can see they're starting to get behind this. Can we afford not to take action? And I think the resounding answer to that is, of course not. So, coming back to the UK, and this came out of that study, that 4-year study, is not only is BIM valuable, but we need to change the way we do construction. So they published this report, Construction 2025, and they set these goals. A 33% reduction in installed cost, a 50% reduction in delivery times, a 50% reduction in greenhouse gas emissions, and if they think they do that, they'll have a 50% increase in the export of their construction capabilities to other countries. So, that's a real massive goal, right? So unless you want to see yourselves get reinvaded by the UK because they want to export their capabilities to you, we all need to do this, including my country, right? We all need to adopt this, and they are absolutely leading the way. Because otherwise, the UK is going to be the low-cost provider of construction. And that would be ridiculous. But that's exactly what's going to happen unless we all change the way we do things. All right? They're determined to do it. And the way they're doing that is government is working with private practice, private industry. So that is another key thing to take away from here, is how can you influence and work with your government officials to say, what is the BIM standard for India? It has to start with that, because otherwise you're just fighting uphill. As soon as we can start working together with our governments to actually create standards and require certain practices, it's just hard to do it. So that's another takeaway. All right, so it comes down to what is BIM, right? Because maybe that's why you're here. What is this stuff? Can I buy a 6-pack of BIM? All right, so this is a definition from the UK, and from all the definitions I've seen, I think it's the best. A coordinated set of processes. All right, so number one is BIM is a process. It's not a product, right? There's no BIM on the shelf. It's a set of processes supported by technology that adds value through creating, managing, and sharing the properties of an asset over the life cycle. So some real key points in here. If you're not addressing life cycle, you're not doing BIM. You can't simply do BIM and design and say, we did BIM. All right? It has to be across life cycle. Properties of an asset. What are those? All right, so COBE is about trying to say what the properties of an asset are, right? That's one of the areas that area, that BIM form that I mentioned from the U.S. And then we have to create it, manage it, and share it. So here's an idea of what properties of an asset might be. Everything has to get down to the component level, and there we need to know what it is. It has to have a unique ID. We need to understand what system it belongs to. What is it a subsystem of? What functions does it perform? Where is it? And perhaps things like who made it, when was it installed, what did it cost, who last maintained it as it moves through its life cycle. Continue to have information about the component. All right, so those are properties of an asset that we'd want to be getting. So the UK and now the industry says there's multiple levels of BIM. BIM levels 1, 2, and 3. And 1 addresses this issue of design, and in design there's a lot of things we can do, but one of the things we get out of this level is visualization, the ability to be able to see something in 3D. So we've been designing in 2D forever. We live in a 3D world. What sense does that make? None, right? We should be in 3D. It's obvious because that's how we see things. So we get much better visualization here. But let me describe these two axes. On the vertical side, we're talking about the actual modeling. And if we do a good job of modeling, we should end up with better performing assets. That's the payback from doing better modeling. And on the horizontal axis, that's mobility. That's the ability to have information moving through this life cycle that I talked about. If we do that well, we're going to have better performing projects. So BIM is really about producing better performing assets through better performing projects. That's what we're really trying to accomplish here. So BIM level 2, we're now into construction. And in construction, we ought to be able to do simulation. Two things that in simulation that we can do. On the one hand, we can simulate the operational design to make sure that it'll actually meet the specification of the asset we're building. That can be fully simulated. We can do lots of different options until we know that, gee, if we construct it right, we're actually going to get the result that we want. But also we can simulate the construction, right? So we can know that this is a constructible asset before we go to construction. It's really a bad time to find out at construction that you've got a conflict, right? That's really an expensive time to learn that. So this really helps in that regard. And then finally, BIM level 3, we've now moved into operations, and at this point, we have the ability to operate our assets as specified because we can actually be keeping track of how it's actually operating today and compare that to how it's supposed to act. This idea that we could have sensors on a bridge, for example, and know when there's a problem, right? And I'll give you some examples in operations, but once we move into operations and we have a digital model, we can know how an asset ought to perform and compare it against how it's actually performing, and then we can take corrective action. All right, so next I want to get into integrated projects, because everything we're involved in today is an integrated project. There's no such thing as one that isn't. But this is the way things actually look, right? You relate to this as, no one's on the same page. There's lots of conflict. And that slows business down, right? So NIST actually did a study, and this is a little bit dated. It goes back to 2002, where they looked at capital projects, and they concluded that in the U.S. alone we were wasting $16 billion because our design tools didn't talk to each other. But this is the thing that really disturbed me. An estimated 40% of engineering time is dedicated to locating and validating information gathered from disparate systems. Does anyone have that problem? Wasting some time? All right, so we take our most important resource, engineers, and we turn them into file clerks. Turns out they're lousy file clerks, so it takes them longer than a real clerk would take to find the right data. But all the while, they're not doing engineering, because we have lousy systems for keeping track of data. Right? That's just the reality. That's the world we live in. That needs to be fixed. All right, so our approach to that at Bentley is something that we call project-wise. And so I'll talk in the context of project-wise, but this needs to be fixed on every project. Right? This is what an integrated project is. There's three things you need to integrate on a project. First thing you need to integrate is the team. And our teams are increasingly pretty complex. It's no longer that we sit in an office and our other two teammates sit across the desk from us and we're constantly collaborating and exchanging data. Right? That's just not how stuff gets built anymore. First of all, even our own companies have lots of different offices and we're spread out all over. We may be spread out over multiple countries. In addition, you might be the Tier 1 contractor, and there's lots of Tier 3s, and then there's Tier 4s, and then there's an owner. There may be multiple Tier 1s. These are complex ecosystems that come together on a project. So collaborating over a single source of truth in that environment, forget it. No wonder we're wasting 40% of our time. Why isn't it 100% of our time, right? This is just hard. So ProjectWise is about making sure that we can have a single source of truth. We have to solve that problem, right? If you're going to have an integrated team, you have to solve the problem of knowing that that the data is the data. It's the right piece of information. The next thing that needs to be integrated is the data, right? Because it turns out that the data comes from all over the place. This idea that our data is going to come from a single suite of applications and it's going to be miraculously integrated, and isn't that wonderful? That's also a pipe dream, right? That doesn't happen on our projects. The data comes in from all over the place, and it doesn't integrate because it's all from different companies, right? Software products. All right, so that's a big problem. So ProjectWise is also about integrating that data, regardless of where it comes from, and making it act as if it were a single model. I'll talk a little bit about that later. The final thing we have to integrate is the life cycle, right? So that is extending its value along the chain. We have to be able to move this data to the next phase. We can't hit the print button and lose all that data, right? So those are the three things that have to be integrated, and that's what ProjectWise does. So going back to that definition from the UK, it's creating, managing, and sharing the properties of an asset. That's what ProjectWise is about. All right, so here is a typical model. And any model that we deal with, any asset we deal with, has a model that we would say is a federated model. It's federated for two purposes, two reasons. First of all, it's multidiscipline, right? Everything we build is multidiscipline. But secondly, the data comes from all these different applications, right? So that's just truth. Data comes from all over the place, so we need a federated approach to modeling. So the way we do that is something we call an I model. The data comes in from lots of different sources. We run it through a composer that is part of ProjectWise, and we produce this lightweight thing called an I model. And an I model can be shared on lots of different devices, right down to your tablet. So imagine being on site with a tablet, and you have a rich information model that you can query right there in the space of the asset that you're building. Right? That might sound like, oh, that's something that's going to happen in the future. Well, no, that's something that happens right now, every day, on thousands of projects across the globe, right? That can happen right now for you. What's important about this is that the I model knows where each piece of data came from. So when in the field you make a note about something, it knows, oh, that needs to go back to the structural product, right? So you can close the loop. That's pretty important. So we have all these mobile products, all right? They're everywhere. And let me give you a quick use case. Because here's how things happen today. We're going to go out to a job site and do an inspection. We come into the office, we collect the specs, we get the drawings, maybe some budgets, dutifully go out to the site. We hope we remember to bring everything. We start making our red lines. We take a few pictures. At the end of the day, we come back into the office, and now we have to distribute our findings. And again, that works great when you're back in that mode where, those two people work across the desk from you. Here, you do this and you do this. But when we work in a world where the expert on that happens to live in a different country and work for a different company, now we're scanning and emailing, and you get into a disconnected workflow that's impossible to control. But that's the way it works. All right, so instead we do this in a tablet. And because we have a tablet, it's a 3G device, we don't go into the office anyway. We simply download it to our tablet, all that same information. And if we forgot to get something, we download it on the site because we have a wireless connection, right? We can still do all the redlining on our tablet, and we can take as many pictures as you want. And the nice thing about it is every note you make on a component, it knows where that component came from, so it routes it back to the person who needs to do the next thing. It closes the loop. When you're done, you simply sync back to ProjectWise. You never went into the office. All the data is still maintained. The person who needed to be informed is informed. You never printed anything, and you stayed in the digital world. Right? This is a brand new process, right? This is how assets will be built from this day forward. So intelligent infrastructure. And what do we mean by that? So the idea is that you're going to have a digital model that is an exact replica of what you built. So that's that item at the top. And it then can interface with your operational system. So maybe that's your ERP system, your purchasing system, your maintenance management model, or your HR system, all of them, right? It can interface then in the context of this digital model. Why would that be useful? Or how do we get there? So the way we do that is in that design phase, when there's all this work in progress going on, we use ProjectWise to manage that process. But at some point in that process, a decision is made that this component is going to be part of the finished asset. And at that point, there's a handover of that component to something that we refer to as AssetWise. AssetWise is a database-oriented, where it's all about the management of change of that component. And in the course of a project, at some point, every component gets turned over from ProjectWise to AssetWise. And now your asset is fully contained in a database that is now the digital model of what got built. Okay? So can this actually happen? Here's an example. So this is from United Utilities. They're the utility that handles the water in the northwest of the UK. They've got 7 million customers and 42,000 kilometers of pipe. Most of that pipe was installed well over 100 years ago. Right? So do you think they have a digital model of that? You know, the person who used to know where the pipe is dead. It's kind of the way water... So they had to go out. They decided... By the way, their problem was that they were losing about 30% of their water through leakage in their pipes. So they had to go out and create a model, a digital model. They went and surveyed all 42,000 kilometers and recreated a digital model of their pipes. So, what can they now do? They can simulate pressure through their model and see how that pipe responds, and that's the blue line. They can then run that actual pressure through the actual pipes and measure those results, and that's the red line. And the reason there's a difference is they have 30% leakage, right? Which is probably, the world's average is closer to 40%. Imagine that, 40% of the most precious resource on the planet we simply allow to leak out of our pipes every day. It's unacceptable, but it's true. Anyway, they have 30% leakage. That's the gap. So the state of the art for finding where we're leaking is waiting until the water comes out through the road or wherever, right? It pops up through the ground. Oh, there's a leak there. Okay, and we all know that that's the most expensive time to fix anything. So we have a product. It's called the Darwin Calibrator, in which you can run millions of iterations very quickly across your digital model. So you have a digital model, the blue line. You run all these variations. If a leak were here, until you end up with a line that begins to converge to the red line. Because now you've simulated there's a leak here. So this tells you where to go find your leaks in your system. It's not possible unless you have a digital model, right? So we can know that we have a problem in our system. We can know that our asset isn't performing to its specification. But unless we have a digital model that says how it should be performing, we don't know there's a gap. And that's the value of having a digital model of your assets. I'll give you one more example, and then I'll finish up. So this is Crossrail. It's a $24 billion project. It's the first subsurface line through London in well over a decade. 90 kilometers long, 20 kilometers of that of twin-board tunnel. It's connecting to something like 27 stations, and there's 8 new stations being built. It'll take 10 years. Crossrail, and this is their slide, said, we're building 2 crossrails, a physical crossrail and a digital crossrail. So from the very beginning, they say, we are going to build a digital model as well as the physical asset. Because we know with a digital model, we'll be able to maintain this asset for the longest time period, doing exactly what it's supposed to do for the cheapest possible price. So spending money up front can save us a lot of money in the future. So they're building 2 crossrails. And that's the point here. Information modeling, the promise of information modeling is that we can save money, we can build our assets more efficiently, and we can operate them more efficiently. And we all know that the money we spend in design is paled by comparison to construction, which is then paled again by the costs and operations. So if we can keep our assets operating as intended for the longest time possible, and what other definition of sustainability is there than that? Isn't it worth spending some money up front? But it means we have to change what we're doing. And we have to adopt BIM. It's a process. Technology helps us create, managing, and sharing information. That information is the property of the assets across life cycle. The promise is, just in this one sector, construction, saving all this money, doing it faster, reducing greenhouse gas emissions, and if you want to keep the UK out of here, you better do it yourself too. Thank you.